In the United States, the Americans are using computers to try to construct pictures of children who've changed since they disappeared. There's a computer at CBC's The Journal, which we thought might be capable of showing us how this is done. Gordon Morris, a CBC graphic artist, said he would try the experiment of aging Sean just for Wonderstruck. First, he had to put Sean's photo under a camera to store it in the computer. This is called digitizing. Remember, this is an experiment. We also gave Gordon an old picture of Sean's mother to work from. It gave him a few clues which Betty didn't have.
He seems to have his mother's hair. I would say it would be a lot darker than it is now.
The chances are he might have gone darker, but I don't know what the mother's hair is like, so I'll stay with the blonde.
So obviously the first thing I got to do is get rid of the mustache, because a little boy that age doesn't have a mustache. So I'll start by just carefully working through and pushing the mustache through.
The lip isn't clear on this one. I have to guess on that.
Mustache is basically gone. Now, what I want to do is just flip him around because he's facing the wrong way. So I'm going to start with another function which allows me to do that. Now he'll be facing the same direction as the little boy. Okay, so what I want to do now is I'm going to take the father's parts of the father and sort of blend them into the little boy and see how that works. Start off by saving just the father's eyes, because that's one area that I think they're very similar.
Now the hairstyle I changed as well from the side part and shorter hair to what the boys wear their hair as now, parted in the middle, basically a three-layer hairstyle.
Gordon found this picture of a 12-year-old in a Sears catalog and thought he might resemble Sean today. So first he colored him, then he turned him, and gave Sean the Sears boy's mouth. Sean still had baby hair, so Gordon fixed that. Betty's final portrait was finished within a month. Gordon's within 2 days, but Gordon was doing his after the fact for us at Wonderstruck. The fact? Yes. Only 6 days after Betty's portrait was released to all the police departments in Canada and the media, Sean was found. He was living in Calgary with his mother, whom we didn't tell you also disappeared 10 years ago, taking Sean with her. The police actually found Sean thanks to a tip-off, but they used Betty's portrait to identify him. Sean thought the portrait was pretty close, except for the hair color. What do you think? Here's the real Sean today, and Betty's portrait, and Gordon's computer graphic. Some children, like Sean, disappear because one parent takes them away from another. Much more rarely, a child can disappear with a stranger. Recently, Betty Clark has been working on aging the picture of one child like that. Her name is Tanya Morell. She's from Edmonton, Alberta, and she's been missing for 3 years.
I can't imagine anything worse than losing your children and not knowing what has happened to them. I know if it was myself, I'd be devastated, and I would like any efforts to be made in finding my children if it were mine, and I'd like to help them any way I could. Now, I know genetically she has a long jaw. Her mother and her brother has a long jaw, so we'll keep that long jaw in. She has very large ears, much larger than a normal girl her age, and that might be a recognizable feature if someone sees her. Plus she has a small birthmark, barely visible there, on her cheek. This is Betty Clark's portrait of Tanya Morell as she may look today at age 11. If you see her anywhere in your neighborhood, please call the police. It came back. You've probably been hearing in the media a lot about Halley's Comet, and maybe you're even getting ready to go out into your backyard and try to catch a view of it. You may also have heard that a comet is sometimes defined as a dirty snowball. Well, the kind of snowball that a comet is made of is different from the kind of snowball that you would throw at your friends. And to find out what a comet is made of, based on accurate scientific data,
David Dodge, our astronomer in Vancouver, is going to make one for us right here in our little cooking show on cooking with comets.
Cooking with comets.
Okay, so you've got some assorted ingredients here that might be what a comet is made of.
That's right. We've been looking at comets for a long time, spectroscoping, and we know there's minerals and stuff. So what we're going to do is take these minerals with the dry ice and water ice, mix them together, and make our own dirty snowball.
Okay, so we start with...
Let's begin.
Okay.
First off, can you give me the water ice?
The water ice. Okay, now this is one kind of ice that might be in a comet. It's just ordinary, everyday ice.
That's right. We'll take a little bit of that.
Crushed ice.
I'll take a little bit of that. And this is dry ice. Frozen carbon dioxide.
Okay, now it's super cold.
Oh, it's well below zero.
Well below 100 below zero, I think.
At least 100, 175 or so degrees below zero.
Okay, that's why you're wearing the glove.
You're right.
Okay. Now that's because space is a very cold environment, so you can get other ices that we don't necessarily get naturally on the Earth.
That's right. All right. Now we need some minerals.
Minerals.
Okay. Let's start with the sand.
Dirt. Okay. That's ergo the dirty snowball.
This is one of the. This is only one part of the dirt.
Okay. Now what's that?
Oh, this is asphalt.
Asphalt.
Hydrocarbons. We've got all kinds of different hydrocarbons on our table here.
Now, a hydrocarbon is something that's based on carbon, and as I understand it, I'm and you are made of carbon.
So is the camera.
And the camera. I mean, most things we know are based on carbon.
Yeah. Carbon with the hydrogen and stuff like that. And this dirt I scraped off my shoe before we started the shot.
All right.
And we have more almost pure carbon. This is graphite.
Okay. Now, by putting carbon in there, we're not saying that there's life on a comet.
Oh, no. Whoa.
Interesting ingredients. Oh, wow. Nice effect.
Yes.
All right, so we're getting a nice, dirty mixture of...
oh, you haven't seen anything yet.
Oh.
Now, more hydrocarbons.
Right.
More hydrocarbons. Give me more hydrocarbons.
Okay. Ah, oil.
Stuff I had in my car yesterday.
Yes.
Drain the tank.
So far...
Ooh, this is lovely. Oh. Well, are you sure the universe was started this way? Now we mix the oil up with our other hydrocarbons and our dirt and our sand.
The oil's acting like a very nice glue there to hold it
sure
all
is. Yeah. This is the egg in the batter.
Right.
Holds the whole thing together. Yeah, Comet spends all of its time in the total vacuum of space and most of its time way, way out from the sun. So we have to create the vacuum, not the vacuum, but the cold temperatures.
The super cold of space.
And if you reach down beside you, there's a silver bottle. This contains liquid nitrogen.
This is over 200 degrees below zero,
yes.
I believe.
Yes.
Celsius.
Now I'm wearing gloves, and you will have to wear gloves too if you do this experiment.
It's super cold because you can't handle. That's why I'm not touching anything here.
Oh, well, if we just broke up a little bit.
Ah, there it is.
There's our dirty snowball.
Funny, weird thing.
Now we're seeing material come off here. This could be called the tail.
Right.
What's happening with the real comet is the sunlight, is the heat from the sun and the pressure from the sun is heating up the comet and forcing the material to come away.
Right.
Now the tail in a comet always points away from the sun. That means if the sun was down here, the tail would be pointing up.
So then there's a period in a comet's life when it's actually riding tail first.
We're going to see that in April, March and April. Now all we have to do with this thing is go down to Cape Kennedy, put it in the next space shuttle, fire it into space, and we'll have our own comet.
And everyone will come out at night, point up into the sky and say, there goes the Dodge Comet.